everybody, this is going to be a video about your 5 different types of chemical reactions. When you are looking at these 5 different types of chemical reactions, just remember that these ones are sort of examples of how reactions kind of come about. So they kind of follow these 5 different ways. So these are just the 5 different ways we'll talk about. I know that it's 5, but you can sort of look at them in pairs. So the first 2 are sort of opposites of each other. So the first one is called synthesis reaction. And why we call it a synthesis reaction is because we're actually making something. So you have sort of one atom, one and plus another one. This is going to give you a bigger one because they combine to make your synthesized compound. You might have been introduced something of the generic formula of this, which is A plus B is equal to AB, which is if you mix A and B together, you're going to have AB as a compound. A real example of this is when you mix sulfur and iron together. So if we mix iron solid plus sulfur solid, you're actually going to make something which is iron sulfide, as you can see in the video right here. Another one, or the second type of reaction, is actually opposite of this. So instead of making something, you're actually breaking down that big thing. So this is called a decomposition reaction, which is you're decomposing, you're breaking it down to simpler things. So just like this one is completely reverse of this, you start off with one big compound and you break it into one smaller one and then another smaller one. So instead of having A plus B, you have AB first, and this breaks down into A plus B. A real life example of this is your hydrogen peroxide, which you can get at your pharmacies, which you can use to sort of clean your wounds and all that. Hydrogen peroxide actually can decompose, and it decomposes into your water plus oxygen. And if you might have seen this elephant toothpaste experiment where you get this big foam, what is generating is a lot of oxygen gas, which kind of becomes this foam because you put detergent in. But that's what happens in hydrogen peroxide when they decompose. You form a lot and very fast, a lot of oxygen gas. So this is your decomposition reaction. The next 2 is called single displacement and double displacement. So these are your next 2 pairs. And how they kind of work together is that for single displacement, basically you're just switching partners with one of them. So what this looks like is that you start up with one thing and you're going to mix that one thing with a compound that is already paired up together. So this one is your HCl. And you must be wondering, well, does that then switch places with Cl or does it switch with H? Well, the answer to that is that you have to look at the charges. Remember, it has to be positive and negative to kind of form an ionic compound. So since Cl is negative and H is positive, zinc is in your transition metals. It's in that little dip of your periodic table, and that means it's going to be positive. So you're not going to switch places with Cl because zinc and H won't really combine with each other because both of them will be positive. So what's going to happen is that your zinc is going to switch and swap places with H+. So you can see here, this was my zinc and this is my Cl, and these guys right here are my H's, or my hydrogens. And you must be wondering, why do I need 2 of them? Well, to answer that, H is your diatomic molecule, so it has to be 2, or has to combine to itself when it's by itself. And then you must be wondering, why do I need 2 Cl's? Well, zinc actually has a 2+ charge, and each Cl has 1- charge. So to balance the charges, you will need 2 Cl's to combine and balance with your 2+. So that's your single displacement. One of them is going to get swapped. And to sort of move on to the 4th one, which is your double displacement, which is basically instead of switching one thing, you're going to switch 2 things. So here you have, we're going to have this example of Pb, which is your lead, and NO3, which is your nitrate, and this kind of compound right here is your K and I, which is your potassium iodide. So instead of just having one of these combine or switch places, you are having 2 things switch places. And you must be wondering which one. Well, if you understood the single displacement as in you're going to switch the positive charges, double displacement is the same thing. So you're going to look at your positive charges and you're going to switch places with them. So I'm just going to go and clone these ones. So this is my lead, is right here, and then these ones are my nitrates. I'm just going to put them over here, and you're going to see how they're going to switch places. So right now, this lead has to switch places with K. So I'm going to write this and let you see it. So this is going to switch places with K. So what's lead's new partner here? Well, it's not nitrate, it's iodide. So lead 2+ is going to combine with iodide. And then the next one is going to be K. So K is going to get swapped, and then here's your nitrate. But wait a second, are my charges all balanced? So let's look at this. Remember, this is my lead, and it's 2+, and this is my nitrate. Oh no, never mind, I was confused myself. This is actually my iodide, was I-, and this orange one is your K+, and this blue one is my nitrate, which is 1-. So are my charges balanced? Well, each of these lead is a 2+. This iodine is 1-, so I don't have enough to balance this, so I need another one. So I'm going to clone one more. So now my charges are balanced because I have 2 iodides to bond with this 2+ lead. What about my potassium nitrate? Well, this is what I have. K is my +1, or 1+, and nitrate is 1-, and they will cancel out with each other, and there you go. So this is my double displacement. Basically, your positives get switched places, or you can look at it, the negative gets switched places, but just make sure you're balancing the charges, and that's the key. And the last one is a big combustion one, which is it's actually pretty straightforward because you're going to have hydrogen carbon, which is sort of your gas, anything you light on fire with the help of oxygen. And hydrocarbon is going to be composed of carbon, hydrogen, and oxygen, just like something like propane gas that we used for our barbecues. So that's C3H8. You can see that has carbon and hydrogen. In order to light this, we need oxygen. We can't just light it in space in a vacuum. So what's going to happen when we light it and you see this big boom? Well, you're going to give off a lot of CO2 and you're going to get water as a product. So every time you light this in a combustion reaction, you're going to get CO2 and H2O. You must be wondering, well, how can it all kind of work out to make CO2 and H2O? Well, because all of your reactants, your hydrocarbons and oxygen, are only composed of carbon, hydrogen, and oxygen. That's why in your products you have carbon, oxygen, and hydrogen. You're not going to get nitrogen or manganese or any other element because that's what you started off with. So for combustion, you're going to get this. So check out these videos about these examples and check them out. Hopefully this helped you with your different types of chemical reactions. So see you later.